Hello and welcome to C++ Weekly. I am your host, Jason Turner. In this episode, I want to talk a little bit about the new C++ 23 fold algorithms. I'm not going to go into great detail except to make you aware of them. But I do want to illustrate one particular aspect of these fold algorithms that I think is particularly helpful and interesting. This episode is sponsored by JetBrains, and I wanted to let you know that I do personally use CLion in my work. I find the refactoring tools to be particularly valuable. The safe delete feature has saved me a ton of time when I've been doing refactoring on large projects. I can get analysis of my compile time checks and see when something is wrong or fails to compile right here in my IDE. So be sure to check out the links in the video description for a discount code and more information about how you can check out CLion. Fold operations were added in C++ 23. You have fold left first, fold right first, fold left with iter, and fold left first with iter. You also have the numeric algorithm called accumulate, and you have reduce, which was added in C++ 17. And the description here is it's similar to accumulate except out of order. The main point of reduce is that it's non-deterministic. We don't know if it's going to add elements 0, 1, 2, 3, 4, 5 or whatever. It's going to add them in whatever order it feels like adding them. And this can actually be incredibly helpful for parallelization. A left fold is going to expand to something like this. It's going to first calculate the initial value with the operation of the 0th value. And then it is going to take the result of that and use that as the first parameter to calling this operation again with the second parameter, etc., continued down for all of the parameters. A right fold is going to calculate the last thing first and then work its way towards the first parameter. Sure. So what is the practical difference of these? Well, if you're doing something like an addition, it doesn't matter. If you're doing something like a division, whatever, it might matter. So if the order of operations matters exactly, then yes, it's going to make a difference. But the thing that I want to call your attention to is the fold left first. I'm going to make an example here, and if you've watched this channel for a while, you probably know where this is going. I'm going to go ahead and accumulate the values of this container and print the results. And you can go ahead and take a moment to count this up and see that once I execute the code, that the result will surely match what you have added up in your head, which is 21. Of course, that's what you expected, right? Now, of course, that is not what you expected. You expected some sort of floating point value. This is not a whole round integer. The problem is that I passed the initial value of 0 to accumulate. In passing the initial value of 0 to accumulate, I have made it do integer division. And as I've already complained about on this channel several times, Clang and GCC both exempt their own standard library from emitting warnings. So you will never get a warning from Clang or GCC. That is unfortunate. Visual Studio will give you a warning with this code. I'm going to now go ahead and use fold left first. This is a ranges algorithm, so I don't have to do the begin and end thing. And it does not have a default operation, so I am going to tell it to use the plus operator. And I'm using this handy functional helper here. Now I'm getting a compile error because fold left first actually returns an optional, which is not my favorite decision personally, but it makes sense because if I passed it an empty set of data, then it can't return a result to me. It doesn't have an initial value to go from. It has to return an optional because it might not have been able to actually do this computation. But assuming I have at least one value, it's going to start with that first value and then do this plus addition in a fold left manner, working its way up to the end value. So I have to actually access the value in the optional and pass that to print. This code does potentially have undefined behavior in it if I'm trying to access the value of this thing without checking to see if it has a value yet or whatever. So as you can see, the result of this addition is actually 23.1. So while this may seem a little bit more wordy in some ways, I actually prefer it in some ways as well because it's impossible to get the type wrong. But then you actually have to check to make sure that it did do the addition for you. I don't know. Something to consider. So there are the new fold algorithms, including fold left first and fold right first, which I think are algorithms that you should know exist. So thank you for watching this episode of C++ Weekly. Be sure to subscribe.